So this is section 5.3. The objectives for today are the student will be able to graph radical functions, write transformations of radical functions, and graph parabolas and circles. So hopefully when we finish today, you'll feel good about that. The first thing we're going to do is we're just going to look at the core concept on page 252 in the textbook. So if we look at this, we're going to work with two types of functions in this section. We're going to do square roots and cube roots. And so they give the parent function. Now remember, parent functions are the simplest one we can have. So the simplest square root we can have would be the square root of x. And if we were to make a chart for that, we would start with 0, because we can't do square roots of negative numbers. And the square root of 0 is 0. And then the square root of 1 is 1. Now you can do 2, but you get a decimal. So let's just skip to the next number we can take the square root of, which is 4. And the square root of 4 is 2. And then 9, and the square root of that would be 3. And then you can go 16 and 4 and so on. So the graph would look something like this. And the domain, remember the domain is the x values. The domain starts at 0 with the x values and then goes up as we go across here. And the range is the y values, and the y values have a lowest point at 0 and then go up from there. And so y is greater than or equal to 0. When you do a cube root, again, the parent function would be the cube root of x. And if we were to make a chart for that, the cube root of 0 is 0, the cube root of 1 is 1, and you can do 2 and get decimals, or 3, but I'm going to go to 8 because the cube root of 8 is 2. Well, cube roots, remember, we can also do the negative roots. So the cube root of negative 1 would be negative 1, and the cube root of negative 8 would be negative 2. And so it gives us a graph like this. And the domain and range for both of them, because there's no breaks in the x-axis, and it goes for up forever here to the left, and down, or to the right, and forever down to the left. And so the range would also be all real numbers. So we're going to work with this today. And they're going to have you graph functions. Now, I'm going to show you the way the textbook does it, and it doesn't make any difference. You always want to start with what makes this, what's inside the square root of 0, because again, you can't do negative numbers. So you could just set 1/4 x equal to 0 and multiply by 4 and get x equals 0. So that would be our starting point. So when you put in 0, you get out 0. Then they put in 4, 8, 12, and 16. You can see you get decimals here. I try and avoid the decimals so I can do it without a calculator. And so what I do is I always take what's inside this square root, and I say, what makes that equal to the numbers that I can take the square root of? So 0, 1, 4, and 9. And so you just solve this like you normally would. You'd multiply both sides by 4. So that means for x, I'm going to put in 0, 4, 16, and 36. And I can make my chart. And when I plug in 0, I get out the square root of 0 is 0. When I plug in 1, or 4, I get 1. And the square root of 1 is 1. And when I plug in 16, 1/4 times 16 is 4, and the square root of 4 is 2. And when I plug in 36, I get 4 to 36 is 9, and the square root of 9 is 3. And so you can see I avoid the decimals that they got in here. It's the same graph. I'm just going to go at 0. At 4, I'm going to be at 1. Now I'd have to go out to 16, but again, that would get me to 2. So I'm going to get the same graph. It just, I don't have to get decimals and guess where they're at. So it's totally up to you. You can put in any numbers you want. Again, the only thing you have to make sure of is what makes that equal to 0. The same thing with cubes, the cube root. So you can see again they have decimals here when they just chose numbers to plug in. And that's fine, you can do that. But again, what I like to do is say, well, I want to take numbers I can take the cube root of, which is 0, 1, and 8, because this is just x there, and negative 1 and negative 8. So the cube root of negative 8 is negative 2 times negative 3 is positive 6. The cube root of negative 1 is negative 1 times negative 3 is 3. The cube root of 0 is 0 times negative 3 is 0. The cube root of 1 is 1, so negative 3 and negative 6. And so you can see on the graph here, they get this graph, and so they just have that. I would have, you know, more numbers. I'd go out to 8. But again, all you need is a rough graph of these. They don't have to be perfect, so just get enough information. So like if I was graphing this one, I would just kind of say, oh, it's here at 0, 0. At 1, we're at, where did I have this? Oh, here at 1, we're at -3. And at 8, we'd be out here at -6. And at 1, we're at 3. And then up here, we're out here. And so I just get a rough graph of this. So your graphs don't have to be perfect. Just get estimates of what it would look like so you have just a rough idea of how that looks. And so we did these two right here. The big thing would be the domain and range. So if we go back to this, remember the domain starts at 0, so the domain would be x is greater than or equal to 0, and the y values constantly go up, so y is greater than or equal to, and it starts at 0. On this one again, it would be all real numbers because there's no breaks on the x-axis, and it goes forever down and forever up. So both the domain and the range in this case would be all real numbers. Okay? So first part's pretty easy. Just again, you can put any numbers you want in and get decimals and make approximations. It doesn't make any difference. So now we're going to go to the next core concept, which again is in the book, and it's totally up to you on this. You've already done all of this before. We're just going to do it with square roots and cube roots. And that is transformations. So here in the book, they've got great examples of it. Just remember, if it's horizontal, it's the inverse of what it says. So when it says -2, horizontal, again, it just affects the x, so that's left to right. So that would be 2 to the right. +3 would be 3 to the left for -3. If it's outside, it's vertical, and it is what it says it is, so up 7 and down 1. Remember reflections, if it just affects the x, it's in the y-axis. If it's outside, it's in the x-axis or over the x-axis. The big thing people make mistakes on is the horizontal stretch and shrink. Remember, if it's horizontal, it says 3x. Remember, it's the reciprocal of what it says, so it would be 1/3, so that would be a horizontal shrink by 1/3. And 1/2, again, the reciprocal of that would be 2, and so it would be a horizontal stretch by a factor of 2. If it's outside, then it is what it says it is. So 5 times 4 is a vertical stretch of 4, and 1/5 would be a vertical shrink of 1/5. So there's nothing new on that. It's what we've done before. And so they're going to ask you to do things like this. They're going to ask you to describe the transformation of f, represented by g, and then graph it. So here they gave us the parent function, the square root of x, which we already know what that looks like. At 0, we're at 0. At 1, we're at 1. At 4, we're at 2, and so it looks like this. And so when I describe this, since it's -3, that would be right 3. And the positive 4 is outside, so that would be up 4. And so all I want you to do when you graph this, you're over 3, up 4, and then just freehand it. Okay, I just want to know that you understood how it moved and what it's going to look like. Now let's do one where it's the cube root. So again, we have our parent function, which we already know. At 0, we're at 0. At 1, we're at 1. At 8, we're at 2. So it's going to look like this way. And then at -1, we're at -1. At -8, we're at -2. So it's going to look something like this. Okay? So, the negative sign tells us it's going to reflect over the y-axis. So that means this is going to come over here and be going up, and this is going to go over here and be going down. And then 8 tells us a horizontal shrink because it's reciprocal of 1/8. So if I shrink it horizontally, that's going to compress it and make those lines get wider. And so all I would need to show on this is I want you to show that it's wider and that you understand, whoops, that it's wider and that you understand that it's gotten further away from the x-axis. Because we shrink it this way, that's going to bring those lines together and separate them. And so that's all you have to do for those graphs. Just a quick graph of this. So if we look at the next one, it says graph this. Well, remember that's a +1 and it's inside, so it just affects the x, so that would move it 1 to the left. So again, all I need to see is, that you understand that it went to the left, and that would be your graph. Okay? And we know that would cross at 1 and so on. So just a rough graph of those is all you have to give. Describe the transformation. So this would be of the parent function, this would be down 2. So what I would want to see on this, that you understand what the parent function looks about like this. It's just going to go down 2. So it's going to be like this. And like that. So that's all you have to do for the graphs. They don't have to be perfect. Just give a rough estimate of where they are. The last thing is we're going to solve equations that have square roots and cube roots. And to do that, we're going to use the graphing calculator. And so there's 2 steps here. Now, really when I give these steps, it's if you're using a TI-83, TI-84, TI-85, not the Desmos. The Desmos, you can just plug it in the way it looks and be done. And so when it says, the steps are, first thing solve for y, and then type it into the calculator. So we look at one here. So if I was going to do this on my TI-83, I would have to get y by itself, so I'd times both sides by 2, and get y squared equals 2x, and then take the square root of both sides. And remember that when I take the square root, it's plus or minus. And then on your graphing calculator, you'd have to put in for y1 the square root of 2x, and for y2 you'd have to put in, because remember it's plus or minus, negative square root of 2x to get your graph. So now let's go to the Desmos app and look at that. So I'd have to do this. I'd have to type in y equals the square root of 2x, and then I'd have to type in another one, y equals a negative square root of 2x. And what I get is when it's the y squared, remember we worked with quadratics where we had the x squared, our parabolas opened up or down? Well, when it's y squared instead, then it opens left or right. And so I can do this, I can put it in separately, which you'll have to do if you're not using a Desmos app, or maybe some other calculators do it. Or you can just type it in the way the equation said originally, which was 1/2 y squared. Whoops. Better remember to come outside it. Y squared equals x. Okay? And if I graph that, you can see it's the exact same graph, but it gives it to me just in 1. So I can delete these, and you can see it doesn't, whoops. So 1 divided by 2, y squared equals x. Gives me the same graph at one time. So you can just type in the equations the way they are. It makes it really easy. And so what they're going to ask you to do is tell the vertex. Well, the vertex is the same, the changing point. So that would be 0, 0. And they're going to ask you which way it opens, which is to the right. So when we go back to this, this would be, our vertex would be 0, 0, and it would open right. This is a circle. Okay, we're going to graph both parabolas and circles. And again, because it's the Desmos, we can just type that in. So you can just type in x squared plus y squared equals 16. And you get your circle. And then all they're asking you to do is to tell intercepts, well, the intercepts are where it crosses the y-axis and where it crosses the x-axis. So you can get all of those. They would be -4, 0, 0, 4, 4, 0, and and 0, -4. And then they ask you to tell what the radius is, which is pretty easy also, since the center is at 0, 0, and it's out to 4, that the radius would be 4. And so all you have to do on those is go through and identify the radius, which the radius would equal 4, and our intercepts again were -4, 0, 0, 4, 4, 0, and 0, -4. So that's what you have to do on that. So, fairly easy. We've got a couple more examples here if you need them. You can try these on your own and then come back and check it if you want. So you can pause it here and try these, and then come back and check. So if you do these, again, we're just going to have to type this in. So -4y squared equals x plus 1. -4y squared equals, what was it? X plus 1. X plus 1. So we get our graph. Your vertex is -1, 0, and it opens left. And then let's look at the circle. The circle is x squared plus y squared equals 25. X squared plus y squared equals 25. And you can see your vertices, or your intercepts, are at 0, 5, and so on. And our radius would be 5, and you're done. So on the assignment is page 254, 333 the odds, 41, 47, 61 the odds. You don't need to graph 19 and 25 on your paperwork. So on some of these it's matching, but I'd still like you when you turn in your paperwork to do freehand graphs of those, just so you get the idea and practice of that, and so you're ready to do it when we get to the test. So, it's a pretty quick lesson. Hopefully